All right, section 2.2 is graphs of relations and functions. So we talked last time about some algebra associated with relations and functions. We also talked about some sort of mappings or some groupings or pairings and how we decide if something is a relation or a function. And today we're going to look at the graphs of these. And specifically, we're going to look at 7 basic graphs. So these are graphs that you may be familiar with. You may sort of generally know what they look like. So I'm going to ask you, and if you do, just let me know. And if you're wrong, it's okay. We'll figure it out together. This is a graph of y equal x squared. Can anybody describe what this sort of has an image of? What is it? A U. It looks like a U. You're exactly right. And we call it a parabola, so that may be a familiar word to you as well. If you were to graph this on your calculator or on a computer graphing device, it would look very much, like Chris said, like a U. And as we're looking at this, we're going to identify some features, main features of this graph. In particular, we talked last time about what domain and range are. If you remember, domain is x values, range is y values. And we're also going to take a look today at some descriptive phrases, increasing, decreasing, and constant. So on this one, if I'm walking from the left-hand side of my graph to the right-hand side of my graph, looking up and down as I go, where do my x values start? Yeah, negative infinity. They start all the way over there at negative infinity. And where do they end? Positive infinity, right? There is no place where I look up and down, in particular on this one up, where I don't see part of my graph. Okay, range means climbing up the y-axis. I'm starting at the bottom of the graph and coming up. Where is the first location where I see y values? At 0. And it actually is a bracket at 0. That's exactly where it starts. And then how far do I have to keep climbing up? To infinity. So my range is negative. It's from 0 to infinity on this one. Remember, I'm climbing up the y-axis. Now, when we talk about increasing, decreasing, and constant, what we're talking about is we're moving from the left-hand side to the right-hand side, just like we do on domain. And we're asking ourselves, as I'm moving along the graph, is the graph going down or is it going up? So we're going to read our graphs just like you would read English, from left to right. So if you start on the left-hand side of the graph and you're moving towards the right-hand side, what initially is your graph doing? It's decreasing, right? This graph's going downhill if you go from left to right. And it starts going downhill on the far left at negative infinity. Where does it stop going downhill? At 0. So when we're looking at writing down increasing versus decreasing, I usually write them down from left to right. You could write increasing first just because it's listed here in the list first. I don't care. But it starts out decreasing, and it decreases until I get to 0. What you do is you look at the x values, but you look at what to list them, but you talk about what the y values are doing. So the y values going down means the graph is decreasing. And it's decreasing from the left-hand side, which is negative infinity, all the way till you get to the middle, which is the x equals 0 value. Yep, Maggie?
Whenever you write these, there won't ever be any brackets, right? It'll always be
Yeah, I was about to get to that. I'm glad you mentioned it. Yeah. So there's no brackets when we're talking about increasing, decreasing, and constant, unless you actually were to see something like a closed circle that indicated something or whatever. In particular, what we're talking about is an interval of values where things happen, and we don't talk about what happens on the specific endpoints. So you're right. This book, and that's this book specifically, I have another book that does it differently, goes with parentheses on everything. So anytime you're talking about increasing, decreasing, constant, you're going to see parentheses used. So from 0 and on, moving to the right, what is my graph doing? It's increasing now, right? So it's increasing from 0 to infinity. And it continues on. So on this graph, you don't see any constants. A constant means it's a flat spot. Now, it can change directions, which it certainly did, but it didn't ever actually flatten out for a period of time. That's why there's no constants on this graph. In fact, most of our graphs don't have constants. Okay? It's a familiar graph, hope. You've seen that one before. Has anyone seen the graph of the square root of x before? It's not a v. That's an absolute value, which we will get to later. Yeah, you're right. So Jamie's kind of drawing a picture here in the air. What it actually looks like is it looks like a collapsed, like a fallen over parabola, but only the top half of it. So you end up getting a graph that looks like this. So you can see how that looks like half of a parabola, like fallen down. That's what it looks like. There's really good reason for that. We'll talk about that later. But thinking about this graph, moving from left to right, domain. What x value does this sort of start at? It actually starts at 0 on this one, and it will be a bracket because it equals 0 there. And where do your x values end? Infinity. They don't, right? How about range, moving from the y-axis from the bottom to the top? Yeah, it's 0. And then infinity. It's the same, right? On this one it is. Right, as I'm climbing up the y-axis, start at 0, y value is the lowest y value, and the highest y value continues upward forever. What about increasing, decreasing, and constant on this? What's that? There's no constant, so that's good. We'll just mark none on that one.
There's no decreasing.
There's no decreasing either. You're right. Never goes downhill from moving from left to right, which means it's always increasing. So what interval is it increasing?
0 to infinity.
Yep, 0 to infinity. Right, from the left-hand side, which hits at 0 until infinity. Number 3 is very interesting how it's written. How is number 3 written in a different way than 1 and 2 were? It says x equals instead of y equals. Do you have a question, Maggie?
I was just wondering, because you wrote a bracket and I didn't know if that was...
Oh, I shouldn't have. I'm so sorry. Thank you for clarifying. You're right. It should say a parenthesis. Thanks. Okay. Number 3 says x equals y squared. Okay. Check this out. If I were to square both sides of this equation, what would I get? Yeah, I would get y squared equals x, or x equals y squared, right? I would get this equation. So these two must have sort of a lot to do with each other, right? They're very related. Well, here's the kicker. Remember I described number 2 as a parabola on its side and only half? Well, number 3 really is the parabola on its side. It's the other half. So why do I get that? Well, take a look at what happens here if I take the square root. So this is something some of you forgot on your test, that plus or minus, right? So the plus gives you the top half of the parabola, just like number 2 had, and the negative gives you the bottom half of the parabola that was missing before. Now we didn't actually write this down, so we're going to go back and we're going to catch it. On number 1, was it a function? Yes. Vertical line test, right? No problem. This one is a function. Number 2, is it a function?
Yeah.
Careful, 2 is on the left-hand side.
2 is.
2 is, yes, this one's a function. Again, it passes the vertical line test. And number 3, nope, right? I cross the graph twice, almost every time I drop a line. So this one is not a function. It's still a graph. We can still talk about it. Your calculator doesn't draw it very well for you because it has a function notation sort of set up inside of it already. But we can still look at domain and range and all that good stuff. Okay? So domain, moving from left to right. What's my domain for number 3?
0 to
Yep, still 0 to infinity, just like the last problem. Yes, I have more values, but they aren't giving me any more x values than I had before. But my range is different. What's my range on this one if I'm climbing up the y-axis?
Maybe infinity to
You're right. Negative infinity to infinity. Because of this piece down here continuing to go down really slowly, but still, it's going down forever. Now, there's something that is very interesting that happens when we have something that's not a function. In particular, every time that we've talked about increasing, decreasing, and constant, we've already had a function that we were talking about, right? 1 and 2 are functions. We can talk about the x values going from left to right and what they're doing. But we actually can't even talk about increasing and decreasing and constant on this problem because it's not a function. And that description only makes sense because it's defined in the context of functions to begin with. All right? The context doesn't work for it to actually even have increasing, decreasing context language imposed upon it. So we don't have to answer that kind of question. So in particular, what would you see on like my math lab? Well, you wouldn't see them ask that part of the question. It just doesn't exist for that problem. All right, next one, x cubed. You guys seen that one before? Do you remember what it looks like? Okay. It does kind of look like a snake. It looks like this. Does that look like a familiar graph? It's a cubic graph. What's the domain for this graph? Negative infinity to infinity. Range. Yeah. Increasing, decreasing, constant. For which one? Okay, so it's increasing. What did you say it was, Chris? I agree, but more. There's, what is it?
Negative infinity to
Yep.
infinity.
Negative infinity. Oops, I'm on the wrong line. All right. No, I am. I'm right. Negative infinity to infinity. This graph is actually always increasing as well. So it starts from the far left. You're always moving upwards along this graph. So this one is increasing everywhere, which means it's not decreasing and it's not constant, right? Okay, so think about what happened when we had y equal x squared. We had this parabola opening upward like this, right? And when we did x equal y squared, it flipped it over to the side. Do you guys remember that? Okay, we just had this image and it just fell. Well, the same thing happens on a cube root when you compare it to a cube. It's the same image and it looks like it's fallen. So the image when you have this one, it looks like this. Can you see how it looks like it's fallen? It actually looks like it's fallen and flipped a little bit, but you can still see how it looks like it's sort of, trying not to use the word for what it really is, but it's an inverse is what it is. And we'll talk more about those later, but it looks like it's fallen over on its side somehow. However, what's the domain? Yep, the same thing. And the range? Same thing. And what can you tell me about increasing, decreasing, constant for this graph?
Also the same.
It's actually the same too, isn't it? It's increasing everywhere as well. It looks different, but it's still increasing everywhere. And it's not decreasing, and it's not constant. How about function status? Are these functions? Yep, they're both functions. And that's why it makes sense that we can actually talk about the increasing, decreasing, and constant is because they are both functions. All right, 2 more. I'm going to be super, super impressed if anyone has any clue what that graph looks like, because it looks really funny the way I wrote it. This is actually a graph of a circle. So if I were to square both sides, it would look like this, right? And if I were to move the x squared to the left, it would look like this. And I'd have the standard form of a circle centered at the origin of radius r. So this image that this actually creates, I'll shift it. looks like that. It's a graph of circle. So let's first answer the is it a function question. Nope, not a function. Now, in particular, from the equation standpoint, how could I know, without me even drawing it, how could I know that this is not a function? Well, the vertical line test is from the graph, that's true. But without the graph, what would I have known before that? There's an r squared. That's not what does it, though. You're right, there is. It's that plus or minus. And that's actually what happened over here on number 3 as well. This plus or minus that shows up when I try to solve it for y, right, creates two pieces of a graph that are layered on top of each other. So on ours right here, I have the top half of a circle layered on the bottom half of the circle. I had a top half of the parabola, the bottom half of the parabola. So this one's not a function, and because it's not a function, we can't even talk about the increasing, decreasing constant, right? Okay. Now, I mentioned that it had a radius of r. So all these lengths are r, right? So this is the most interesting one that we've done so far with domain and range. What's the domain? Very good. And I use brackets, right, Maggie? Yep. It starts at negative r on the x-axis, and it comes all the way over to positive r on the y or on the x-axis. Right, here's negative r, and here's positive r. And if I'm climbing up the y-axis, what's my range? Yeah, it's the same thing, isn't it? And that kind of makes sense. I mean, circles are pretty symmetric. Don't have much else that's any better in terms of symmetry. So we do not have a function. All right, the last one is the one that you hit on earlier, Chris, is that absolute value. And you told me what it was going to look like. What did you say? It's a V. This one's a V shape. So I end up with a graph that looks like this. Let me shift it over just a touch. Okay, I have a V-shaped graph. Is it a function? Yes, it is. This one is a function. What's the domain? Yep, negative infinity to positive infinity. What's the range? With a bracket, right? 0 to infinity. What about increasing and decreasing and constant? Let's start with constant. Where's constant? Never. Yeah, we haven't seen one that is, but none. How about the increasing and decreasing? For which one? Okay, so from the far left-hand side, the negative infinity until I get to 0, it's decreasing. So this is negative infinity to 0. And then from 0 on, it's increasing. All right. The last examples in this section all have to do with graphs that are sort of manipulations of the basic graphs that I've shown you. They're all like these, but they're like shifted around a little bit, or they're pieced together in a different way. So they're all a little bit more unique. And so my goal is not necessarily that you have to be able to draw these graphs because you have a calculator, and I'm cool right now with the idea that you're going to use your calculator to help you make some of those decisions. But I will show you some different ideas about how to think about them as well. Now this graph is pretty nice in terms of solving because I can just move my y to the other side. So this is just the equation y equal x. And you should know what that equation looks like, right? It's your basic line. I could have put this into the first set, probably. So what is the domain for this line? Yep, negative infinity to infinity. What's the range? Same. Somebody tell me what you see about increasing, decreasing, or constant. It's increasing everywhere, right? Yeah. So this one is increasing from negative infinity to infinity, and it's got no places where it's decreasing or constant. All right. Now the next equation is much more interesting. On this next equation, you have those absolute values. So the basic shape's going to be a V because there's an absolute value here. If you don't know where the absolute value button is in your calculator to give yourself some perspective, ask somebody in the Success Center, ask somebody in the class, ask me. I'll show you where it is in your calculator, okay? You can find it there. If you aren't sure and you don't want to find it, or maybe your calculator is not a graphing calculator, that's okay too. The basic idea here is that I've got an addition of 1, and so it's going to shift it somehow, left, right, up, or down. And we'll talk more about shifting these graphs later. But you can create a very nice table of values to get an idea of what is happening here. And in particular, how do you choose your values? Well, often it's nice to start by choosing your values so that you end up with 0 on the inside. For example, if I chose x is equal to -1, that zeroes out the inside, right? It does. So what's -1 plus 1? 0. What's the absolute value of 0? 0. And what's a negative times 0? It's 0. So having that nice middle starting spot, that's going to be that corner of my absolute value. And then shifting on either side. So now I'm going to do one smaller and one bigger. So smaller than -1 is -2, and bigger than -1 is 0. And these are not special points. Like I don't have to pick -2 and 0. If you want to pick 3 and -7, go for it. Doesn't matter. They're just some options. So if I pick -2, what's -2 plus 1? -1. What's the absolute value of -1? +1. And then what's the negative here going to do in the front? Make it another -1, right? So this gives me -1. And let's do it with 0. 0 plus 1 is 1. Absolute value of 1 is 1. And then the negative in front makes it -1. So in terms of graphing these points, this point would be -1, 0. This point would be -2, -1. And this point would be 0, -1. And I already know it's supposed to have the shape of a V, so I can connect it. Okay? So we have those basic graphs as our fallback for deciding what's the basic shape going to look like. Is it a parabola? Is it a line? Is it a V? What does it look like? This is a V. And then we can answer the same questions we already had. So what is the domain for this graph? Yeah, all of our domains are -infinity to +infinity, huh? What's our range? Starting at the very bottom. -infinity all the way up to where? Is it -1? It's 0. So when we're looking at the range, we're always looking at what the y values are, not x values. That's the only time we do that. So -infinity up to a 0 for the y values. That one's the tricky one. How about increasing, decreasing? Right. So it's increasing from -infinity to -1. So we do stop at the x value -1. You're right. And then it decreases from -1 to infinity. Still, there's no constants. Okay. So here's what I need to tell you. I'm still recording for those who aren't here so that you know. Obviously, we're not done with this lesson, just so you know. So this one won't be due until Wednesday. Here's also what you need to know. I will not be here on Monday, so I'll be posting videos anyway. I have a court situation that I need to take care of with my daughter, and it has to be done on Monday morning, so it interferes with our class, unfortunately. I'll send adjusted office hours as well, because it will also affect my Monday office hours. But I'll be posting videos for the rest of this section. Also for section 1.3. 2.3, whatever we're on next, 2.3. And we'll see the length of that as to whether or not anything in 2.4 gets posted. But we're pushed back a little bit on our schedule. It'll be okay. So there won't be a quiz until we're done with the sections that it says in the syllabus. I will send an email that will clearly identify all the adjustments that I've just said out loud. Okay? So stay tuned for that email. Have a great weekend, guys.